Hi, this is Nimla Rednam. In this video, we are going to start the topic Exponents and Powers, which is the 10th chapter from NCERT textbook class 8. We are going to learn about the 6 laws of exponents and also the standard form of a given number in exponential form. So before going into the laws of exponents, let's first understand what do we mean by exponential form, right? So suppose that I have something like this. This is the exponential form. It is read as a raised to the power m, where this a is called the base and m is called the exponent, right? And what does this a power m represent? It is simply the number a multiplied m number of times. That is nothing but a power m. If I have a number being multiplied by itself m number of times, we write it as a raised to m, right? So now let's look at the laws. The first one says a power m into a power n is equal to a power m plus n. The next one, a power m by a power n is equal to a power m minus n. The third one is a power m whole power n is equal to a power mn. The fourth one says a power m into b power m is equal to ab whole power m. The fifth one, a power m by b power m is equal to a by b whole power m. And the last one, a power 0 is equal to 1, right? So these are the 6 laws of exponents. So if you look at the first one, let's quickly look at the proof of it so that there is no confusion when you have to use them quickly. You shouldn't be confused about what is a power m into a power n. So if you look at a power m, we already know that it is a multiplied m times. Now into a power n is again a multiplied n times, right? So this is m times and this is n times. Now when I'm multiplying these two, that means effectively I'm multiplying a m plus n times. That is, I have m plus n number of a's in this product. So this is nothing but, and this is a power m, this is a power n, and this is a power m plus n, right? That is the proof for the first law. When it comes to the second one, I have a m times in the numerator, right? And I have a n times in the denominator. Now this n can be greater than m or less than n, it doesn't concern us, the result is the same. So now when I have a common factor in the numerator and denominator, we know that I can cancel it, right? So I'm going to cancel them. If m were greater than n, then after cancelling all the a's in the denominator, I'm going to be left with m minus n a's in the numerator, and therefore the result will be a power m minus n. Even if we had the other case, that is m is less than n, or in the case of m equal to n, you know that this is going to be a power 0, which is 1. And if m is less than n, what's going to happen is all the terms in the numerator will get cancelled, and what we are left with is a few terms in the denominator, right? So on. And this is nothing but, because this is n minus m in the denominator, right? So these two effectively are going to be clubbed into this once you understand the remaining laws of exponents. So this is about your second law of exponent. Coming to the third one, I have a power m whole power n. That is, I have a power m, which is a having a m times, right? And such that if I consider it as one set, okay, one box of m A's, in that manner, how many boxes am I going to have? I'm going to have n number of such boxes or brackets. These are n in number, right? So now, in total, how many A's do I have? That's the only question I need to have clarity about. So I have m in one bracket and m in another bracket. So if you consider the first two brackets, I have m plus m, that is 2m. Okay, another m A's in the third bracket, another m A's in the fourth bracket, so on like that. How many brackets do I have? Or if you want, you can imagine boxes of m A's each. I have n such brackets, right? So what is the sum when I add m n number of times? The sum is going to be m n. So this is nothing but a raised to mn. Mn is nothing but m into n, or m times n, or n times n. So that is your third law, right? So in the first three laws, you must have noticed that we have a common base, that is, I have base a. Now when it comes to the fourth and fifth, you will see that you have two different bases, but the exponents happen to be the same. You can see the exponent happens to be the same. Okay, so in the exam, whenever you come across a question, first you need to identify, are the bases same or the exponents same? Because if the bases are same, you are going to think about the first three laws. If the exponents are the same, then you're talking about the fourth and fifth law, right? So let's look at the fourth law. It says a power m into b power m, right? So I have a m number of times, right, into b m number of times. Now I'm going to look at pairing these. So if I write a into b as ab, right, the second a with second b, the third a with third b, so on, the mth a with mth b. So I have how many ab's here? I have m ab's here. So that means I can write this as ab whole power m. So that's how we are going to look at it. That is your fourth law. In the fifth law, I have a power m by b power m. Here again, the exponent is the same, but the bases are different. So here I have a m number of times in the numerator, b m number of times in the denominator, right? So now I'm going to regroup it or write it or look at it in this manner. A by b, so on, a by b. Okay. So here, how many such a by b's do I have? M, which is nothing but a by b whole power m, right? So that is your fifth law of exponent. Now the sixth law says a power 0. Now what do you mean by a raised to 0? I told you a raised to m means that you're multiplying a m number of times. So when you're saying a raised to 0, that means you're not, all the a's have taken off from that multiplication box. There's nothing left. So you will be left with the multiplicative identity, which is 1. That is one way of looking at it. So a power 0 is 1. Now here, you need to understand negative exponent as well here itself. Because when I said a raised to m means multiplying a m number of times, clearly it is possible when m is a positive number. And we have already seen a power 0 is 1. Now what if m is negative? That is, if m is positive, then a raised to minus m, does it have a meaning? It does have a meaning. this notation is nothing but a 1 by a power n. So whenever you have, for example, 2 raised to minus 2, how can I multiply 2 minus 2 number of times? That's not what it means. What it means is you're going to have 2 raised to 2 in the denominator, right? So that is what it means. So this is one more thing that you need to remember along with the 6 laws of exponents. So let us quickly look at the sums from the textbook. So let's look at these, try these questions. Find the multiplicative inverse of each of these. So multiplicative inverse, for example, if you look at 2 power minus 4, okay, what should I multiply this with in order to get 1, right? So you'll see that if I multiply with 2 power 4, this will become minus 4 plus 4, the exponent is going to become 0. So 2 power 0 is 1. So the answer is 2 power 4 is the multiplicative inverse. By the same logic, here the multiplicative inverse is 10 power 5. Over here it is 7 power 2, right, into 7 power 2. Over here it is 5 power 3 and over here it is 10 power 100. Correct? So that is the answer. The next, try this question. Expand the following numbers using exponents. So if you remember in earlier classes, you've looked at expansion, as in if I have 23, the expansion is going to be 2 into 10 plus 3 into 1, right? So as far as the numbers before to the left of the decimal are concerned, it's going to be the same. So I'm going to write 1 into 10 power 4 plus 0 into 10 power 3, 1 into 10 power 3, sorry, right, is going to give me 1000. 1 into 10 power 3 plus 0 into 10 power 2 plus 2 into 10 power 1 plus 5 into 10 power 0, which is 1. Okay. And then I have 6 over here. 6 into 10 power minus 1 will give me 0.6. And 3 into 10 power minus 2 is going to give me 0.03. So that is your expansion. Okay. Using exponents, so we have used exponents. Let us look at this one. 1 into 10 cube plus 2 into 10 square plus 5 into 10 plus 6 into 10 power 0 or 1 you can write, plus 2 into 10 power minus 1 plus 4 into 10 power minus 2 plus 9 into 10 power minus 3. That is your expansion, right? Next is the laws of exponents. We've already discussed this. Now simplify and write in exponential form. Here you can see that the base minus 2 is common. So it is the first law. Minus 3 plus minus 4 is minus 7. Correct? Here also again I have base common. So I'm going to add the powers. 3 plus of minus 10 is minus 7. Here again the base is common and you have 3 terms instead of 2. No problem. You can add all the 3 exponents. 2 minus 5 is minus 3 plus 6 is plus 9. Right? So, sorry, 2 minus 5 is minus 3. Minus 3 plus 6 is plus 3. Correct? Okay. Next, I have example sums. 2 power minus 3 is 1 by 2 cube, which is nothing but 1 by 8. And here I have 1 by 3 power minus 2, so I can write it as 3 power 2, right? Which is nothing but 9. Next, here I have a power m into a power n, which is a power m plus n, minus 4 power minus 5, right? Which is nothing but 1 by minus 4 whole power 5. So that is your answer. And here you can see that this is second law, which is a power m minus a power n. So it is a power m minus of minus 6, which will become plus 6. Right? Next example. 4 power minus 3 as a power. Now here the base is 4, they want to make the base 2. So let's look at the base. Base 4 can be written as 2 square. So 2 square whole power minus 3 is, again, this is the third law. I'll get minus 6, right? So that is how you will solve the sum. Next, simplify and write in exponential form. Here you can see that all the bases are same. So simply you have to concentrate on the exponents. So 2 power, this is m minus n, which is minus 3, right? Plus of minus 5, correct? So this will give you minus 8. So, right, sorry. Here I have 5 times of this. Minus 3 and this whole power 5 into 2 power minus 5. So this is minus 15 minus 5, which is minus 20, right? So with practice you will get more comfortable with this exponential notation, and if you are thorough with the laws of exponents, the sums are pretty straightforward. Now here if you look at the exponent over here is the same and the bases are different for all the three. So what we are going to do is use the fourth law, and you're going to have exponent minus 3 and multiply all these three bases. Minus 4 into 5 into minus 5, which is nothing but 100. So the answer is 100 to the power minus 3, which will be 1 by 100 cube, right? So the third question again, they're asking you to simplify this. You know that 8 is nothing but 2 cube. So you're talking about 2 power minus 3 into 3 power minus 3. Again, this is the fourth law. It is nothing but 6 power minus 3. AB whole power m. Right? So, and then if you look at the fourth question again, you have the common exponent over here. So you'll simply write everything else in the bracket, inside the bracket, and then simplify it. So you'll get minus 5 whole power 4, right? And you can further write it as 5 power 4 because minus 1 whole power 4 is 1. So now you are saying you have to find m. So you can simplify the LHS as minus 3 whole power m plus 6. Now if I have to equate it to this, now because the bases are same, I can equate the powers. So that means m is equal to 1, right? So that is the answer. Find the value of this. Now you have minus 2. First, in order to simplify, I need a positive exponent. So I'm going to write it as 3 by 2 whole square, and then you open the brackets, you're going to get 9 by 4. Next, seventh example, I have 1 by 3 whole power minus 2, which is nothing but, 3 square, right? Because minus is there, so I have to write the reciprocal. 3 square minus 2 cube, right? Divided by 4 square, right? So this is nothing but 9 minus 8, which is 1, divided by 16. So that is your answer. Next, second bit, I have 5 by 8 and 8 by 5, and the exponents are different over here. But you can see that I have a common base. If I open the brackets, I can club the bases separately. So I'm going to write 5 power minus 7 by 5 power minus 5, which I'll be using the second law of exponent, right? So if I simplify this, 7 minus of minus 5 is going to be minus 2, and minus 5 minus of minus 7 is going to be plus 2, right? So this is nothing but 8 by 5 whole square, which is 64 by 25. So you can see that once you know the laws of exponents and you're comfortable with this exponential notation, and immediately whenever you look at something of the form a power n, if you can immediately have the clarity that it means I'm multiplying a m number of times, All these sums are very straightforward, and you can do them in a few minutes. So evaluate, let's start the exercise. Evaluate, the first question says, evaluate 3 power minus 2. This can be done here itself. This is nothing but 1 by 3 square, which is nothing but 1 by 9. Now here evaluate minus 4 whole power minus 2. Whenever you have a negative exponent, going further with the simplification or evaluation of that particular number or that particular expression means that you need the positive exponents first, because this you cannot multiply minus 4 minus 2 number of times. So first get the positive exponent and then simplify it. You will have your answer in no time. And over here it is 2 power 5, which is nothing but 32, right? So the second question, simplify and express the result in power notation with positive exponent. Now they want us to express only in terms of positive exponent. So let me take this up in the whiteboard. Right? So here we are talking about exercise 10.1. Second question, the first one, they are talking about minus 4 divided by, okay, minus 4 power 5 divided by minus 4 power 8, right? So how do I simplify this? First, because I have the same base, this is the second law, 5 minus 8, you have to mention the law, whichever law of exponent you're using, minus 3. Now I want positive exponent. They have specifically asked us for positive. So I'm going to write it as 1 by minus 4 whole cube, right? So the next question, they want us to simplify 1 by 2 cube whole square. This is simply 1 by 2 power 6. 1 power 6 by 2 cube square, which is 2 power 6, right? So that is your second one. The third one, you have minus 3 whole power 4 into, they're saying 5 by 3 whole power 4. Correct? Now here you can see that the bases are quite different, minus 3, 5 by 3, but the exponent is the same. That means I can bring all of these bases under the same bracket, whole power 4. Now I can simplify this and I'll write this as minus 4 whole power 4, and minus 1 multiplied 4 times will give me a positive number. So I can write it as 5 power 4, right? So that is your third question. Fourth question, they're asking us 3 power minus 7 divided by 3 power minus 10 into 3 power minus 5. So here clearly you can see that the bases are same. So it's the first 2 and 3 laws that we'll be using. So inside the bracket I have 3 power minus 7 minus of minus 10, which is 3, right? And into this, so plus of minus 5 is minus 5, which is 3 power minus 2, and they want positive exponent, so I'll write it as 1 by 3 square. Correct? So that is your fourth sum. Fifth question, I have common exponent again, 2 power minus 3 into minus 7 power minus 3. So the exponent is common, bring the bases under the same bracket, minus 3, this is nothing but minus 14 power minus 3. I want a positive exponent. I don't mind negative base, but my exponent has to be positive according to the question. So that is your second question. All done. Let's look at the third question. Find the value of, I think this can be solved here itself. Find the value of 3 power 0, which is 1, plus 1 by 4 into 2 square is 4. So they want us to simplify and tell them the value. 1 plus 1 by 4 is 5 by 4 into 4 is nothing but 5. So that is your answer. Now here, what is this? 1 by 2 into 1 by 4 divided by, what is 2 power minus 2? 2 power minus 2 is 1 by 2 square, which is nothing but 1 by 4. Divided by 1 by 4 means into 4. Reciprocal, right? So the answer is half. Now here I'm going to write it as 2 power. I'm going to take the reciprocal of this, okay, to make this positive. Understood? Because a power minus m is 1 by a power m. So in order to make this positive, I'm writing 1 by 1 by 2, which is nothing but 2. So 2 power 2. And similarly, this becomes 3 square and this becomes 4 square. So there's nothing but 4 plus 9, 13 plus 16, 29. That is my answer. So that is your third question. The fourth bit from the third question says, now whatever is inside, as long as it's not 0, this is the defined and the value is 1. I need not really calculate this also. And even if you were to calculate, it will be 1 by 3 plus 1 by 4 plus 1 by 5 and take the LCM and proceed. But without calculating directly, you can say the answer is 1 because it's whatever is the result, it is raised to the power 0. So that means it's 1 according to the sixth law of exponent. Next question. First, I'm going to make this exponent positive. Okay. So for that, I'm going to write it as minus 3 by 2 whole square. Right? And then whole square. So 2 into 2, I'm going to write it as 4. So I have minus raised to 4 will give me plus. And I have 3 power 4, which is 81 by 2 power 4, which is 16. So that is my answer. Right? So next, fourth question. We'll take it up in the whiteboard. Fourth question. They're asking us 8 power minus 1 into 5 cube by 2 power minus 4. Right? So that is the question. Now, like I said, whenever we want to simplify, I cannot proceed if I have negative exponents. First, make them all positive and then we can think about simplifying it. So I have 2 power 4 over here and 8 power 1 in the denominator. Right? Now my exponents are positive. Now 8 is nothing but 2 cube. So I'm be left with 2 here. And 5 cube is nothing but 125. 125 into 2 is 250. That is my answer. Next, second bit. 5 power minus 1 into 2 power minus 1 into 6 power minus 1. Right? So like I said, I want positive exponents. So 5 into 2 into 6 is going to be in the denominator, which is simply going to give me 1 by 60, and that is the answer. Let's look at the fifth question. Find the value of m if 5 power n divided by 5 power minus 3 is 5 power 5. So I know that here LHS is m minus of minus 3, which is plus 3, is equal to 5 power 5, right? So here the bases are equal. So I'm going to equate the powers, which implies m is equal to 2. So that is my answer. Next, I have a lot of negative powers in the next one. Let us take it up. I'll write the question first. We have fifth question. First bit 1 by 3 whole power minus 1 minus 1 by 4 whole power minus 1 whole power minus 1 whole power minus 1. Now I have a minus b form. There's no law for that. You have to first simplify inside the bracket and then we'll look at the whatever is outside the bracket. So this is nothing but 3 minus 4. Correct? So whatever I have inside the bracket is 3 minus 4. This is nothing but 1 by 3 minus 4 is minus 1 minus 1. So the answer is minus 1. So that is it. The second question, 5 by 8, 8 by 5. This is similar to the solved example that they have given. Let's look at it. So the second question, the second bit, we're talking about 5 by 8 whole power minus 7 into 8 by 5 whole power minus 4. 8 by 5 whole power minus 4. Like they have done in the example, some you can first break it up and then you club the common bases and then simplify. Or another way is to look at it as base as 5 by 8. Or you can take 8 by 5. So here, this can be written as 5 by 8 whole power 4. Correct? I need the reciprocal to make the exponent positive, right? So once you have done that, I have a common base now. The base is 5 by 8. Okay. And now use the first law, minus 7 plus 4 will give you minus 3. Right? And in order to simplify, I don't want any negative. So negative exponents. So make it 8 by 5 whole cube. Now 8 cube is nothing but 512 and 5 cube is nothing but 125. So that is your answer. Right? Next question, 7th one and the last one. Simplify the given expression and you have an unknown, you have a variable as well. But it's once you know the exponential form, it's not a problem whether it's a numerical or a variable. So let us look at this. 25 into t power minus 4 divided by 5 power minus 3 into 10 into t power minus 8. Correct? And clearly t not equal to 0 because the base can't be 0, right? So now how are you going to simplify this? We need common bases. Now 25 can be written as 5 square, right? So first let me write it as 5 square. And over here I have 5 power minus 3 into 10 is 5 into 2, right? And then I have t power minus 4 by t power minus 8. Correct? So here, look at the 5's. I have 2 plus 3 minus 1. Correct? And I have t minus 4 plus 8. And then I have a 2, which is, single. I can club it with any of the other two. So here I have 5 power 4 and I have t power 4 and I have a 2 here, right? So I want the final simplified answer. 5 power 4 is 25 square 625, t power 4 by 2. So that's my final answer. Second bit, 3 power minus 5 into 10 power minus 5 into 125 by 5 power minus 7 into 6 power minus 5. Now you can see that none of the bases or none of the exponents are the same. Once you factorize, you will have clarity. Like for example, 10 is 5 into 2, so you have base 5 over here. 6 is 3 into 2, you have a lot of 3's here. So in that way, we will be able to simplify it further. So in order to simplify it further, first I need the factorized form of all the bases. So let us do that first. 3 power minus 5, I am going to write it as it is. Okay. 10, I am going to write it as 2 into 5, right? And give their powers. And then I have 5 cube. 125 is 5 cube. 5 power minus 7. And again 6, I am going to write it as 2 into 3. Be careful with the powers. Now we are going to write this. First, let us look at base 3. I have minus 5 plus of minus 5, which is minus 10. Sorry, minus of minus 5. M minus n, right? Minus of minus 5, which is plus 5, which will give me 0 exponent and therefore 1. And I have again the same thing with 2. In fact, you can just cancel them here. But let's use the law of exponents. Plus 5. Again, this will cancel off and give me 0 in the exponent and therefore 1 as the result. Now let's look at 5. I have minus 5 plus 3, and these two 7 and 5, when they go to the numerator, will become plus 7 and plus 5. Correct? No, there's only 1. There's no plus 5. There's only 1 over here, plus 7. Okay? So now 3 power 0 is 1, 2 power 0 is 1, and I have 5 power 5. So that is the final answer. So with this, we finish the first exercise, and in the next video, I will be discussing the second exercise.